So for this lecture, I will talk about sampling. Okay, to find things out about a population of interest, it is a common practice to take a sample. A sample is a selection of objects and observations taken from the population of interest. An important aspect of randomized possible confounding variables is taking random samples of a population. Population in the statistical sense is different from a biological population of individuals. It represents all the possible measurements of a particular variable. A random sample is one in which all members of a population have an equal probability of being sampled. Once you've designed your experiment to control as many confounding variables as possible, you need to randomize your samples to make sure that they don't differ in the confounding variables that you can control. For example, let's say you are going to make 20 mice wear sunglasses and leave 20 mice without glasses to see if sunglasses help prevent cataracts. You shouldn't reach into a bucket of 40 mice, grab the first 20 you can catch and put sunglasses on them. The first 20 mice you catch might be easier to catch because they are the slowest, the tamest, or the ones with the longest tails, or you might subconsciously pick out the fattest mice or the cutest mice. I don't know whether having your sunglass wearing mice be slower, tamer, with longer tails, fatter or cuter would make them more or less susceptible to cataracts, but you don't know either. You don't want to find a difference in cataracts between the sunglass wearing and non-sunglass wearing mice, then have to worry that maybe it's the extra fat or longer tails, not the sunglasses, that cause the difference. So initial plan for experimental design should seriously consider the sampling method you want to use, or else you might lead to wrong interpretation. In the mouse example, you use all 40 of your mice for the experiment. Often, you will sample a small number of observations from a much larger population, and it's important that it be a random sample. In a random sample, each individual has an equal probability of being sampled. To get a random sample of 50 oil palm trees from a plantation with 700 oil palm trees, you should figure out how to sample. You need to be careful to make sure that your sample is truly random. For example, a population might be all durians in an orchard at a given time. We wish to know how big the durians are. We can't measure all of them. We take sample of some of them and measure them. The method chosen for taking samples depends on the nature of the population and the resources available in terms of time, efforts, and also money. The ideal is for each object in a population to be equally likely to be chosen as part of the sample. This is called an unbiased sample. It is also desirable for the sample to be representative of the population. If the population of durians were 2/3 Musang King and 1/3 of D24, the sample should be similarly split. This is the rules of thumb in sampling. Note that no matter we do, there will always be sampling error or variation due to sampling, as we are looking at a part of the population, not the whole population. There are two categories of random sampling: probability sampling and non-probability sampling. In non-probability samples, it's where some elements have no chance of being selected. It also involves the selection of elements based on assumptions regarding the population of interest, which forms criteria for selection. For example, if we visit every household on a given street and interview the first person to answer the door in any household with more than one occupant, this is a non-probability sample because some people are more likely to answer the door that us those who are employed, perhaps mothers at home taking care of kids, etc. and etc. Non-probability sample includes convenience sampling, quota sampling, judgment sampling, and also snowballing. You may pause this video and read the text. Next is probability sampling. There are few types of this sampling. First is simple random sample. Simple random sample is theoretically the ideal method of sampling. You list each member of the population and use random numbers to decide which objects are in the sample. Each object is equally likely to be selected. This produces an unbiased sample which we hope is representative. However, it can be difficult and expensive to take simple random sample when dealing with people. Simple random sampling is more practical when the population is geographically concentrated and when a good sampling frame exists. A sampling frame is a list of all the people or objects in the population interest. Simple random sampling can be more easily implemented for natural and manufacturing populations. Simple random sampling can easily be done by automatic generation by your scientific calculator or Microsoft Excel or by using random number table. How to use random number tables? Refer to your table 37 random numbers 1 at page 54 from this statistical tables book. You can also Google it, but most of random numbers tables available online are single digit, while in this book is a double digit random number table. So how to use a random number table? First of all, here is a random number table. What is the purpose of the table? Well, if you make up numbers in your head, they are not always random, no matter how hard you try. The table is used to give you a list of random numbers. These numbers could be used for various reasons. They could be actual numbers or they could represent other data. Let's use the table to stimulate an event. Here, we want to randomly pick 20 students from all 700s. It is only really a random if every one of the 700 has a chance of being picked. First, we can number our participants from 1 to 700 and use a table to collect numbers 1 to 700. But we need to be fair. We have to be consistent. We will create a list of 3-digit numbers so we can capture 1 to 700. 1 here, 1, sorry, I changed the color here. Okay, you see, 1 is will look like 0, 0, 1, and 700 will be 7, 0, 0. This is how it looks like for to read in the random numbers table. And then we pick a random starting point in the table. Then we create 3-digit numbers following the table, go straight across the table and find the next row. So I just randomly pick one row here. And then we start to pick 3-digit numbers. So start for one, the first digit numbers is 162. So we have what, jot down the 162. The second numbers will be 277. And then the next one is 943. Remember that we want the participant is only 1 to 700. So 943 is out of the context. So we ignore the 943. The next number is 949. Again, we ignore the 949. Next is 544. 544. Next is 354. 354. We continue until we get all the 20 numbers. We get 20 numbers that can represent the participants that we want to take. Then remember that the numbers will be between 1 to 700. Let's say you get this 094, means that the number will be 094. This is number 94. So this is so 079 will be number 79. So you just need to pick up the numbers based on the 3-digit numbers. So you just need to list down all this based on the random numbers, okay, from one row to another row. So be consistent using this row. Don't jump like me, just one side to another. So now try with this. Can you find 5 random numbers between 100 to 1000? Whoa. Next is systematic sampling. With systematic sampling, you choose a starting point at random and then systematically take objects at a certain number apart. For example, if there are 100 in the population and you want to take a sample of 20, so 100 divided by 20, you get 5. So and you want to, so you will take every fifth object to get your sample. So you count one by one. Also, this is 1, 2, 3, 4. So 5. This is the fifth one. 1, 2, 3, 4, 5. This is the second one. 1, 2, 3, 4, 5. And then you continue 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 until you get 20 participants or 20 person that you want to collect, 20 samples that you want to collect from the whole population here. Okay, so that's how you do the systematic samples. So systematic samples are easier to administer than simple random samples and are usually a good approximation of a random sample. However, if there is a pattern in the population, certain types of objects could be chosen more or less often than others. Another one is in the systematic sampling, the chances, some people have no chances to be selected because you only take every fifth of the sample from the population. Next is cluster sampling. This sampling is usually used for the heterogeneous population which cannot be predicted. Sample all the individual from several subunits which have randomly been chosen. For example, to determine the biomass in the forest, or this one to determine the population of a weed, a very heterogeneous and clustered. Sometimes a few have very high biomass, others have very low biomass, and the method that usually used in cluster sampling is quadrat sampling. This is by using quadrat. In cluster sampling, the population is divided into clusters, which are then chosen at random. Such as for this one, we chose at section 1, section 2, section 3, 4, and 5. Sample units not identified independently but in a group or clusters. These provide logistical advantage. Like here, once we cluster, we randomly choose to survey section 1 and section 5 only. And within the section 1 and section 5, we try to sample only within the section only, within the cluster. Whole population is divided into groups such as neighborhood. Okay, like this. Random sample will be taken from these groups only, for these groups or clusters only. Within each cluster, all of the objects are included in the sample or random sample of these units. From these samples, we can choose all the individuals in this group, or just we use another random samples within the classes that we want. Cluster sampling can be more convenient and practical than simple random sampling. However, if the clusters are different from each other with regards to the elements we are measuring, it can lead to bias or non-representative. So for cluster sampling, it is convenient and practical. However, there is a possible bias and also non-representative. Next is stratified sampling. Stratified sampling seems like cluster sampling, but the strata or groups are chosen specifically to represent different characteristics within the population, such as types, variety, ethnicity, location, age, or occupation. So they can create groups here: group 1, group 2, group 3, group 4. So based on the different colors of the apples. Within each group, a random sample is taken, sometimes in proportion of the size of the group. So we do the random sampling and then choose the apples that we want to be sampled from each group. So this is what we call as the stratified sampling. Stratified sampling can lead to a very good random representative sample. However, it can be complex to administer, and a sampling frame with considerable information about the population is required. There are other sampling methods. The methods explained here only give an idea of the advantages and disadvantages of various methods. You should attempt to use a sampling method that produces the best results for the resources you have available. When you're sampling, you need to consider how much time do you need to do the sampling. Do you have all the effort? Do you have all the energy? Do you have all the do you have the effort to do all the sampling that you want? And also some resources. So sometimes money also play a role in the sampling. And finally, if your sample has known bias, this should be taken into account in analysis and reporting.